Okay, so I'm going to be working on the first two competencies for college algebra, and you'll see those are to recognize a function and specify its domain and range, and then number 2, to graph a linear, quadratic, and some various types of functions. We'll focus on linear and quadratic in this lesson. And so if you haven't already, if you will, find the document that I sent you, smartphone calculator exercise, and follow along. You'll also need your smartphone, but I bet you have that, so that's all probably good. And we're going to be downloading an app using the app. And the one I like that I've used is Calculate 84. You can see here on the handout. Step 1, we're going to try to graph the equation 2x minus 3y equals 12. And step 1 would be that you need to solve this equation for y. All equations we solve for y to use this application. And I am going to teach the lesson as if you've never used a graphing calculator, because some of my students have never used a graphing calculator. So I want to always approach it as if it's brand new to everyone. And I know it's not to you guys, but just bear with me. That's how I would do this. So the app looks like this. You can see Calculate 84 to make sure you found that one, and you may need to pause the video to get that downloaded so we can use that. And then if you'll go ahead and open up your app, and we're going to go ahead and plug in this first equation. I've solved it in terms of y, and I would assume that is a skill, though, that we have gone over in class and students would be able to do, although I will check on them about that, and I'll have them check on their neighbors. So plug in y1, 2/3 x minus 4. Another thing is sometimes the students have trouble finding the X button if they've not used this before, to know that, and you may need to know this as well, that it's the third row down, second one in is how we get the X to show up on the screen. It has some other features as well, but if you just hit in the first feature, the X shows up. And I would go over or refer them to this handout that there are 10 basic features that we'll use that go along with the graphing application, and we could talk about each one of these to give them some comfort, give them some time to look through each one of these, read these as well. And so you will notice that along the first row we've got the main feature buttons, and they're white, and y equals is the main one. We type in our equation, y equals always, and there's room to put in other equations, but we'll just be graphing one equation at a time. But I would mention that later in the semester we can type in a second equation and look for where the solution to a system would be. So that's something we'll use later. But that, and then the graphing feature, let's go ahead and hit that and look at our picture of our equation. Okay, then let's go ahead and look at the next page, our exercise, and practice. Let's practice. So I've taken this equation, and you can see the steps here as well to solve it for y, and then we've already put it in our graphing calculator screen. Then I would ask the students to do these activities, and ideally we would be able to work in groups, and the students would be in groups of 2 or 3 and be able to compare their work and talk to each other about that. And for you guys as well, I know you're watching this on video, so that may not be an option for you either. So, but no, I would say that, and we would do this as a group exercise. And I would give them time then to explore these, and you can do that as well if you want to pause the video and take some time to think about these questions. But I'm going to go ahead and assume you did that and continue on. But notice, because it is a smartphone, we have a touch screen here, so we're able to use the trace feature. Even though there's a trace button here, you can hit trace and you can move the graphing calculator with the side arrows like we used to do. But because it's a touch screen with a smartphone, we can pick that up and move the little button along that way. It's touch screen. So, and notice as we move it, you'll see points given along the bottom of the screen, your XY coordinates, and that helps students to get a feel for all the coordinates, that they're not just the the 3 that we see sometimes, that we make a t-table and look at the 3, 0, 1, and 2, but there's many other points, and also leading us to that idea of domain and range when we do that there's lots of x, y coordinates, infinite amounts that we work our way up to talking about. So I think that's good. They're able to touch and move that along. And then to try to estimate where the x-intercept would be. So try to put the cursor on the x-axis to understand what an x-intercept is, and look at the point along the bottom of the screen. Then we would talk about how the true x-intercepts when y equals 0 algebraically, and we would do some of that as well, and equation solve, and look at the value. It's I think the answer is supposed to be 6, so I'm going to keep trying, and I can't get the cursor to be exactly on 6 for some reason, maybe the pixels, but I get really close, so I would estimate 6 there. And then for your y-intercept, same thing. Try to get it on your y-axis so students can understand what a y-intercept means. And then we can use one of the features, which is the second. I don't know if you can see this well enough on the video recording. It's hard to see anyway, but above each one of these white buttons, there's a second feature. So I would explain to the students, you have to hit the second and then hit that. So stat plot, table setup, and the one we're going to use right now is calculate. So second of trace is calculate, and it has some handy features like finding the 0. So you can go down, or you can just touch screen it. It does ask you to put your cursor on the left hand side of where you think the 0 is going to be, and we would talk about how a 0 is an x-intercept. Another way of saying x-intercept, or a solution to the equation, that those are kind of synonymous. So we put our cursor on the left-hand bound, and it has a little question mark, so we hit enter. We kind of know we did that. And then the right-hand side of that intercept, hit enter, and then it will tell you that the 0 is exactly at 6. And so it gives you the value of the 0. And so we'll see some other equations as we have time here. Maybe we'll talk about how we can find multiple x-intercepts by using that feature on parabolas and larger functions. All right, so let's see. Then I would ask them to verify that by plugging in, doing it algebraically. Plug in y is 0 back to our original equation. What if we plug in y is 0 and have them solve that to verify their answer and check on their neighbor? And then I also want to use the table feature, so let's do that. Hit second of graph, and let's look at the table values. And so it's good to go up and down that screen and look at all the various t-table values that it's given us. And to locate, I would ask them to locate when y is 0 and see that it's also in our table of values. We can see it in that way as well. And then number 5, verify this by looking at the table. So yes, that's where I'm at. Number 6, I mean. Then I want to verify more points. I want to show them algebraically. Maybe I'll pick something like 9 and 2. But I would say pick something off of your table. Everybody pick something off your table. And plug that in for x and that in for y back in the original equation, and show your work that it also works. For example, 2 times 9 minus 3 times 2, and show that you can show the arithmetic and the steps that verifies the point to also feel, the algebraic work. And then checking on their classmates as well. Then we might play around with the window feature to show how that if we had a large equation like this one fit in the screen well, we can see the x-intercept and the y-intercept in the 10 by 10 grid, but we might want to have, if we had a large equation like x plus y equals 100, it's not going to fit in that screen, so we might need to count by 10s or 20s or something different. So we would play around with the window feature and talk about how we can change that scaling. That window allows us to really just draw our graph. If we were drawing on our paper, to count by X scale, counts by 1s is the default, but we can change that to count by 2s and so on. So we talk about that and have them practice that, and then also how we change it back. Also, I would mention that Z standard, where that is, we use that a lot, I feel like, and in the Zoom, under Zoom, there is a Zoom Fit, or sorry, Zoom Standard. I don't know if you use that one a lot, but Zoom Standard, and then you can hit enter, and it takes it to your 10 by 10 screen. That's kind of the standard screen. But also we talk about how things don't always fit in that screen. And then we would take time to do it again, and I can see I'm talking too long, so I don't know how long I'm going to have to do that. But then we would practice another one, do 5x plus 2y equals 10. If you'd like to pause the video and do that for your own fun, you're welcome to do that. So this time I want to talk about slope, domain, and range and function, which gets more to our competencies, deeper into what could X be. And I feel like this graphing calculator app is good to explore that there's more points than just the typical 0, 1, and 2 that a lot of times students stick with. I do want them to list 3 points that's on the graph by looking at the table of values. So let's go ahead and I may not work through all of the steps as much to save some time, but let's get this equation in our calculator and talk about slope with the students. So we talk about solving for y each time, and then going back, hit clear. So -5 divided by 2 this time, x plus 5 graph. And so to list at least 3 points on the graph, I would like them to be able to, they can do it by hand on their own algebra if they want, but ideally they're able to look at the table of values and pick some XY points off of the table of values. And then we would talk about what are your thoughts about the slope, the slant of the line. And we would talk about how that when we read the graph left to right, this graph is going downhill. It's a negative slope. And we would also talk about our algebra, how that what's in front of the x, the slope is negative this time, and how it looks on the screen. And then the biggie is getting to domain and range, and how that the screen stops here and here, but actually when we look at the table of values, the numbers continue much further than what you can see in our window. And to look at these values and try to determine what the domain and range is. What do you think X and Y could be in general? And so we would develop that and talk about how that if we drew this graph on our own paper, that we would draw arrows for a reason to show that the graph keeps going. And also I think we could add in here the table setup to say these are just integers in the default, but if we go to table setup, we can tell it to go by a half. Or that's 1.5, isn't it? I need to clear. But we could tell it to give us fractional amounts as well. So now when we go to table of values, okay, now we have some of the decimal values. So decimals can also be in the domain, and we could make that number even smaller. So we could talk about these table of values, but we can also look at how they connect, and that the domain keeps going left and right without bound. So I feel like it's a good way to develop domain and range by looking at this table of values. And then we would talk about what a function is and how you can look through your table that no x is repeated, but also we can look at our picture and say the vertical line test. So we would do that, exchange our papers, talk about it. Then we would go ahead to look at parabolas and talk about domain and range of other types of equations as well. I'm going to go ahead and move to the square root one. I can tell I'm running out of time. I think I only had the 15 minutes. I'm right at it. But you could just talk all day about various types of functions, right? But I think you'll have the gist of it, how I would use this technology in the class to develop domain and range from the different features on the graphing calculator. So we could do a square root. So I'm going to move to number 4, and the square root of x minus 1. We will practice putting that in our calculator to see something that's not domains, just not everything goes, and what that looks like on the table of values. So I would use my square root. So let's type that in. This one's already solved for y, so y equals the square root of x minus 1. And then when we hit graph, it looks a lot different than our line. So we could talk about, is there a slope on that? Is it a function, domain and range? And what I think the domain is, where it starts and how it goes over. But then when I hit table of values, I feel like this is very helpful to see. There's certain values that give you an error reading. You can't plug this into that function. And where exactly does that happen? So we would talk about domain and range not being just everything negative infinity to positive infinity, but it looks like 1 is the first number, and sometimes there's even a fractional amount, not on this one, but 1 is the first number that is allowable to plug into our equation for x and give us a real answer for y of 0. So we would say the domain starts at 1. So anyway, I think I'll wrap it up with that. I don't think I have time to get through the others, but hope that was helpful.